Today we'll talk about advances in biogas flowmeters. This presentation is intended for the 2023 BBI Biomass Conference, and the presentation is intended for educational use only. The material is from me, unless specifically citing or quoting a source. The presentation does not necessarily represent the thoughts of my employer. There are no warranties or other offers implied by this presentation. Process equipment and instrumentation should be installed, operated, serviced, and maintained by qualified personnel. No responsibility is assumed by the presenter, his employer, or BBI for any consequences arising from the use of this material. Sources are provided for photos and images not from my collection. Unless otherwise mentioned, this presentation addresses the USA market. So thank you for being here today. If you're a child of the 70s or 80s, maybe you remember the TV show where what's going to happen to Larry Hagman on Dallas. This is part one. This is a cliffhanger. I'll be followed by Steve Milford of Endress and Hauser in a later presentation. So stay tuned. Just a brief bit about Eastern Controls. That's my employer. Over on the left, you see our geographic location. We handle level, flow, pressure, temperature, analytical, valves, gas flame detection, gas analyzers, chromatographs, heat trace, and the hardware that and services that run an RNG plant, in addition to PLCs, RTUs, and HMIs. So to start off, we have to think to ourselves, do we love methane or do we hate it? This presentation will feature biogas and renewable natural gas, which will explain the differences in here in just a minute. But you look on the left, the UN, methane has accounted for roughly 30% of global warming. And on the right, we've got a utility who's used to burning coal and fuel oil and things like that. They say methane provides a great environmental benefit. So it really depends on your perspective. And do we love or hate methane? Well, it's complicated. So today we'll talk about biogas and renewable natural gas. So to explain the difference between the two, biogas is gas that's between 45 and 65% methane. Renewable natural gas is biogas that's been upgraded to where it may have a methane content of 90% or greater. There is a difference. So you see me here today, and thank you for having me, and thank you for attending the presentation. But you think, okay, so you sell flow meters, analyzers, and things like that. What's the big deal? And it depends on your perspective, which we'll talk about in a minute. From our perspective, though, we're helping to keep personnel at the plant alive with H2S and CH4 detection. We're helping to keep the bugs alive in the digester, which we'll talk about in a minute. We make sure that they're emitting the proper percentage of methane. Our analyzers ensure the quality of the natural gas that ultimately gets injected into the pipeline or may be made into bio-CNG. And we keep the pipes flowing. If you think about heat trace and the places where some of these plants are going, they're not in the best environments. Not everything can be warm, sunny Atlanta. Sometimes these are going up in New York, in the Northern Hemisphere. We have to put freeze protection on to keep the pipes flowing. So here's a look at some of the players. We'll talk about each of them and address their individual needs. But overall, the universal needs, everybody wants to see the same thing. Obviously, we're in business for return on investment and profit. But as these projects are going up quickly, everybody is involved in risk reduction as they build the plants and speed to market, getting things built quickly. So from a vendor perspective, and I see myself as a vendor along with digester suppliers, gas upgrading skid suppliers, we want to be able to be involved in the project early. The earlier we're involved, generally, the better. That allows us to help specify equipment that may be special for the renewable natural gas and biogas market. Just besides the typical project stuff, the scope, the timeline, the project spend, the budget and things like that, we also want to know where you're going. Where will your plant be built? And the reason we ask this is we want to staff ourselves up to be able to go to those remote locations to perform services. Builders, they're at risk. It's tough to build these plants. It's certainly no easy task, so they're trying to reduce their risk wherever they can. Finding the available labor and trades, making sure the equipment shows up on time, and avoid the scope creep. These builders do such a good job when they build the plants. Often we're trying to throw other things at them and take other things into their scope. We've got the parties that actually produce the biogas. So these are your landfills, your food banks, food digesters, farms, things like that. And they can either keep the gas themselves and use that free biogas to run their plant, provide some electricity, maybe some hot water, or they could take the gas and sell it to a marketer or a reseller who's going to go collect and help make them a profit. But at the end of the day, it does reduce waste. We're literally taking waste and turning it into energy. So it's good for everybody's portfolio and everybody's business to be able to take what's normally waste and get something out of it. Farms. The farms are unique in this business now. There's a lot of growth in renewable natural gas at dairy farms. So just like everybody else, they want to get a profit for sure. But they can one of the popular applications is before we got into renewable natural gas was just biogas and using something like a Yenbacher engine or something like that on site at the farms. We'll talk about that in just a minute. But they would take that gas, and it was the 45 to 65 often was good enough for some of these engines that could run on biogas. So they could make electricity, they could run boilers, they could run heaters. One of the unique things about the digestate, and that's the solids that are left over from the actual anaerobic digester portion of the process. They use those things, and they can sometimes make profit off them. They can use them internally for animal bedding, fertilizer, and crop irrigation as well. So this is real. This is a video game called Farming Simulator that runs on a PC. And being an instrument guy, we look at the game and we're always looking for the instruments. We're always looking, well, where'd they put the instruments in the game? Well, I don't see any. There are certainly pumps and other portions. You know, you've got a CHP there and a gas upgrading skid, and obviously the digesters. But this is how you know stuff has hit the big time. In Farming Simulator, you can buy a renewable or a biogas plant rather to make electricity, and you can use all these different things for your feedstock. You know, cut beets, slurry, manure. So developers and utilities oftentimes are one in the same. But the developers, what are they doing, and what are they trying to do? It's certainly for the finance, and the finance is very good right now. There's a lot of profit to be made in renewable natural gas. Not only can they sell the gas to use in their utilities, but they can collect the RIN credits, the landfill or the low carbon fuel standard credits coming from California, LCFS, and now there are tax credits when they build their plants coming from the investment or the Inflation Recovery Act that was passed last year. It helps them green their portfolio. Certainly, it makes them look better. You know, if you're a fossil fuel company, now you've got some green and some renewable in your portfolio. The gas is also much easier to access. There's typically no drilling involved like you would with a conventional where we're doing fracking or something like that. And it helps them meet their decarbonization goals a little quicker. The other thing is they want to ensure they're staying in compliance with how their permit allowed them to build the plant. And that means meeting EPA, ISO, and other standards. So this is our technician, Justin, on the right, working on a biogas analyzer. One of the things that some of the feedback we get from our customers is the things that they like and want that's helps them succeed in the biogas and renewable natural gas industries are having a single source of inventory. As these plants are being built very quickly, they often come back and they want to do the same thing and replicate that. Things are shipped from the domestic United States in English units, and we service things on site. So that's something that's often of benefit. And they want a vendor who knows how to comply with EPA, Title 40, CFR Part 98. Steve's going to talk about that a little bit more in just a minute, but also help with the Inflation Reduction Act. As often legislation is passed, how do we interpret this and how does it benefit us? Pipelines, utilities, they have to ensure that the gas they're getting meets their quality standards. And these what you see on the screen here is a couple examples of sources of gas quality from the pipeline companies. When it comes to remote support, this is one of the things that a lot of these plants see and desire. You have to have the capability to go to the site and perform services. The sites are remote. They're often not manned by many personnel. So the ability to do that, to calibrate instrumentation, keep the customer in compliance with EPA, Title 40, CFR Part 98 is something very beneficial. And then finally, because the plants are very remote, we want to be able to look at our phones, look at our iPads, look at our laptops, and get an update. What's the gas quality? What's the gas flow rate? How many BTUs am I generating today? All that stuff is available working with a control systems integrator or your vendor for instrumentation, as we can take this information, put it up in the cloud, and securely get it to you as it's happening in real time. What's driving growth in this industry? We're all here today talking about it. If you had to boil it down, it would be the California low carbon fuel standard, LCFS. And the typical project, we're making something in another part of the country or even California, putting it in a pipeline, proving it could get out to California, where California will take that RNG and produce it into bio-CNG. So there's incentives for that, financial incentives, as well as the incentives for the credits from RINs and the Inflation Reduction Act, which we talked about. So there's different types of renewable natural gas. You see here, landfill, wastewater, and dairy. What's unique about the dairy application is that it's actually carbon negative, and that means it takes more carbon out of the environment than it produces. So you have to consider that everything that goes into it, from the production, the transport to the delivery, that's what goes into its carbon intensity score per the California Air Resources Board. So we're seeing more growth in dairy right now because of its carbon intensity. And the big oil and gas companies, the major oil and gas companies, are noticing renewable natural gas. They are acquiring companies, and I'm sure you've seen these in the headlines from the Wall Street Journal. BP bought Archaea. Shell is buying Nature Energy. It's really starting to catch on in the major market. But the plants are still being built, and they're still being built by developers. They're going on farms and landfills, food banks, wastewater treatment plants, and the hockey stick's just going to keep on going up. This chart is from the RNG Coalition. And keep in mind, we talked about the four typical different types of RNG that are produced. When you take just the biogas, and biogas comes off the digester, the bugs eat the fuel or waste, emit methane, and then when we take the H2S and the moisture off of that, then we have biogas that we can use in an engine. If we take the moisture, the H2S, and the CO2 off of it, now we have RNG, 90% methane or higher, that we can use for transportation fuel, or just put it into the grid. This presentation is intended to be taken home and used. I hope you find it helpful. If you'd like to click this link, you'll find a typical biogas plant layout with all the instrumentation within. You click on it and it will highlight the instrument and the application. So something very helpful if you're new to the biogas business. So while we're on the subject of flow meters, what's the biogas flow meter demand? That's the title of this presentation, and Steve's going to certainly talk about it more. What you'll typically see is when developers and builders take out their permits from the EPA, there's often a requirement such as this. The permittee shall calibrate, maintain, and operate a biogas flow meter that shall be placed at the outlet of the covered anaerobic digesters, et cetera, et cetera. Popular place to put one, by the way. Helps monitor the quality of the health of the bugs. But you'll see this often throughout. Sometimes it's buried in the permit or the EPA language. And again, the EPA always wants to ensure that we're complying with their requirements of greenhouse gas monitoring or reporting. They have certain restrictions regarding the calibration and recalibration of the meters. This is what a calibration looks like. We have a remote rig that we take to site. We also have a calibration rig at our facility in Philadelphia. But what we can do is take that to a remote site so the meter doesn't have to travel. But still, the meter has to be pulled out of the process. You have to have a spare if you want to keep running, or you have to wait for the meter to be calibrated. One of the options that we'll discuss a little bit later with Steve is maybe you don't have to calibrate and you can still stay within the EPA requirement. Verification is one way to do that. And keep in mind, when you're monitoring biogas flow, it's different than traditional flow. There's lots of people from lots of industries that got into the biogas business, but as biogas is often very low pressure, we can't use our favorite differential pressure flow meter. It's dirty and wet, and the composition may change, which oftentimes throws out a thermal mass flow meter or a turbine flow meter. And the rates are generally too low to use a vortex flow meter. It's low pressure, wet and dirty, and it comes at a very low flow rate. So there's a specialty market for biogas flow meters, and where they're typically seen, like you saw in the permit, they're often used coming out of the digester into the gas upgrading skid, outside of the gas upgrading skid, and into the flare. There are several other applications, but those are typical for a dairy plant. So back to what we talked about earlier, we're very proud of what we do. The analyzers we manufacture and service help ensure the quality of the gas that comes out of the plants, goes into the pipelines, is used for transportation, fuel, or in our homes. We monitor the health of the personnel, we monitor the health of the bugs, and we keep the pipes flowing. So just to recap, we talked about the market, our mutual needs, the growth of the entire market, where that we're seeing growth in landfill, water, wastewater, food, and especially growth in the dairy, renewable natural gas. We talked about some of the demands that are placed on plants by the EPA in terms of services, issue with some of the current measurement techniques and some of the things we can't use that maybe we've used on other projects, as well as the solution to our needs. And I'll let Steve address that a little bit more as we get into specific biogas flow meters. So thank you so much for your time. I look forward to networking and talking more. You have my contact information and my links here. Thanks a lot.